Hi everyone. We'll continue in chapter 8D, lesson 5, measurement uncertainty. In the previous video, we have represented what's the difference between mistake and error, and also what's the meaning of accurate values and precise value, and what's the difference between two definitions. Now we'll continue on measurements. In the experiment, we use different tools like balance, thermometer, burette. Each one will give me a value. So I will record that value, and that value, I obtain it here, it contains uncertainty. It means I will be doubt of that value in a scale plus minus. Okay, so a plus minus, that scale, I'm uncertain about that value. Okay, so in order to define what's the meaning of uncertainty or measurement uncertainty, it's a potential error involved when I'm using apparatus. Okay, so this apparatus, even I'm using it correctly, but we have it may contain error through an error while they are manufacturing it, or an error from the calibration. So any error involved in that apparatus will give me uncertainty of my measurement. Okay, this is the meaning of measurement uncertainty. In a doubt, or I'm not certain about my value here. Okay, so I can explain it by measurement uncertainty or uncertainty. Okay, let's take an example. The balance. Some balances will give us the value or the mass for 1 decimal place. Other balances, they record the value up to 2 decimal places, and others will give us also other balances. They can give us the values up to 3 decimal places. What's the difference between 1 decimal place, 2 decimal places, and 3 decimal places? When we have more decimal places in my mass or my value, it will give me less uncertainty. So I will be more, I will trust this value more. Okay, so more decimal places, it means more precise values. The values will be more accurate. Okay, so in order to calculate the uncertainty for any value, I will take the half of the smallest digit. The half of the smallest digit. What's the meaning of that? If the balance measure up to 1 decimal place, uncertainty will be plus minus 0.05. It's the half of 0.1. Okay, if the digit or the balance measure the mass up to 2 decimal places, so the uncertainty will be plus minus 0.005. It's the half of 0.01. And also here in the third one, if my balance measures the masses up to 3 decimal places, it means the uncertainty will be the half of that value. It means 0.005. So each time you will divide the digit by you will divide it by 2. Okay, it's the half of the smallest digit. Okay, let's take an example. If my balance give me that value, it means that balance measures up to 1 decimal place. So the uncertainty for that value will be what? It will be plus minus point smallest digit, it's 0.1, so plus minus 0.05. So I will add 0.05 to that value. It will be 16.35 or I will subtract 0.05, so it will be 16.25. Okay, so my uncertainty for that value, it will be between 16.35 or 16.25. This is the uncertainty. So let's take another example. Assume the balance measures masses up to 2 decimal places, like 15.10. Okay, my balance give me a record for the mass. It was 15.10. What is the measurement uncertainty for that value? We are having 2 decimal places here, so the uncertainty will be what? 0.2 decimal places, the half of them, 0.005 plus minus. So I'm uncertain, or I'm in a doubt of that value by what? You will add this value to that value plus, or you will subtract it in the same way we do it in the previous example. Okay, so uncertainty, it's again, we are doubt of my measurement plus minus in a scale of plus minus. Okay, now in your book they mentioned a table. That table, it's very important and useful one. The burette, the capacity of it is what? 50 centimeter cubed. Okay, and we can see on the scale it contains 1 decimal place. It means the uncertainty for the burette, it's what? It's plus minus point, the half of 1 decimal, it's plus minus 0.05. Okay, as they mentioned here, it's a plus minus 0.05, as we have 1 decimal place in the burette readings. And when we read a title, we read it by the difference. We read the initial reading and the final reading, and we subtract them. So each time you read the burette, there is uncertainty in your reading. So you will add this uncertainty, or you multiply it by 2, because we do the reading 2 times. So the uncertainty for 1 burette reading will be what? 0.05 times 2, it's what? Plus minus 0.1. Okay, as we are reading the burette 2 times. The pipette also, the capacity for it, it's 25 centimeter cubed, and the uncertainty for it, it's what? 0.06 centimeter cubed. Volumetric flask, the capacity 250 centimeter cubed, and the capacity for it, it's plus minus